Hello, so in this video we will talk about how we can use counting techniques to prove to simplify some summations. So let's say we have a problem like this. We want to prove that the summation from k is equal to 1 to n, k times n choose k, this is equal to n times 2 to the n minus 1. So we will prove it through counting techniques, and then we will prove it through some mathematical manipulations. Now let's say that we want to use counting techniques first. Okay, let's say our universal set is equal to 1 to all the integers up to n, and we have the task of choosing a set of one element from u which is let's say which is called the leader. Okay, so the question is, this is only one element here, so one element here. So the question is, how many ways can we choose the element of L? We can choose the element of L, so we can say n ways to choose element, one element of L. Why n ways? Because n choose 1, this is equal to n. Okay, now we have the remaining set is u minus L or u minus L. Sometimes this notation is used, sometimes this notation is used when we talk about sets here. Okay, so now we have how many elements here? We have n minus 1 elements in this set of u minus L. Okay, now the point is then how many subsets can be made from u minus L. So this is the same question as saying that what is the cardinality of the power set of u minus L. Okay, now this we know that since the cardinality of u minus L is n minus 1, so the answer to this question is 2 to the n minus 1. Okay, so this means that we have n times 2 to the n minus 1 ways to choose one leader and any subset from the remainder elements. Now note that any subset, when we talk about, that can be an empty set as well. So the worst case is that we have only one leader and no committee at all. Okay, when I say committee, it's like a subset of humans. Do the same thing with a different technique. Okay, what does n choose k mean? So this means that if we have u 1 to n, we choose k elements the first time. So we say that maybe our some set, maybe a, this is equal to a1 up to ak, where a is the subset of u. Now the question is, how many ways can we find? Can we form a? This is n choose k. Okay, now we want to find one leader from a. Okay, so one leader, so L find L from. So how many ways can we find L from a? And remember how many elements we have for L? One element. So therefore there should be k choose 1 or k ways to uh, to form L. So now what is the minimum value of k? Minimum value of k is 1, because remember we can say we have to choose one element, but it should be the remaining committee can be empty, but so then k should go from 1 to n. So this means that there are this summation number of ways to do the same thing, and this is this number of ways to do the same thing. So this means that they should be equal. So this is one way to, once you have combinations and permutations, and we have summations, so we can use some counting techniques to prove such a relationship. Now since we have done that, now let's do it using pure mathematics. Okay, now what we want to say, we say left hand side is equal to k is equal to 1 to n k and k. So what I will do, I will divide by n and multiply by n. Okay, so now this is equal to n times k is equal to 1 to n k over n factorial over k factorial times n minus k factorial, which is equal to n times k is equal to 1 to n minus 1 factorial divided by k minus 1 factorial n minus k factorial, which is equal to n times k is equal to 1 to n minus 1 k minus 1 n minus 1, choose k minus 1. Now this is equal to n times n minus 1 0 plus n minus 1 1 plus n minus 1 to n minus 1. Now this is what I can say, n times 1 to the 0 1 to the n minus 1 times n minus 1 0 plus 1 to the 1 1 to the n minus 2 n minus 1 1 plus, and my last term will be 1 to the n minus 1 1 to the 0 n minus 1 n minus 1. Now if I compare it with a to the 0 b to the n minus 1 n minus 1 0 plus, I'm skipping the terms, so a to the n minus 1 b to the 0 n minus 1, choose n minus 1. So this is what this guy is equal to, n times a plus b to the n minus 1. So in our case we have a is equal to 1 and b is equal to 1. So this means we get n times 2 to the n minus 1, or I can say, if I want to do one more step, I can say n times 1 plus 1 to the n minus 1, which is equal to n times n to the 2 minus 1, 2 to n minus 1. So this is another way to do that. So when you have a problem in which combinations are there and summations are there, so there is usually, not always, but usually there is a way to use some counting techniques to solve the problem or to prove the problem. Okay, otherwise most of the times, almost all of the times, using mathematical approach, just use the formula and use the definition and use some manipulations, you should be able to reach the solution. So hope you learned something from this, and this is important to know in counting techniques. Combinations, permutations, basically they stem from the basic counting techniques, and discrete probabilities also stem from basic counting techniques. So this is it for this video. Hope you like the video. Thanks for watching.